Hello friends, I am Nikita and you are watching Prepare for GATE. Today's topic for our discussion will be MOSFET. We will be covering everything related to this topic, its internal structure as well as its external functions. So, moving with the content of our syllabus, we will be discussing MOSFET and integrated circuit fabrication process. The topic to be discussed will be MOSFET capacitor and MOSFET bias. Moving with what actually MOSFET is and how it is being constructed. It is in the picture you can show it. You can see it's an depletion type MOSFET, and I am discussing here about enhancement type. What is a depletion type MOSFET and what is an enhancement type MOSFET? Basically, the difference lies in the design itself. At the time of manufacturing, in the depletion type MOSFET, the channel is already created by the manufacturer. However, in the enhancement type MOSFET, the channel is not created. On applying VGS voltage, the channel starts creating. So we'll find the problem of channel modulation in enhancement type, not in depletion type. Okay, so an enhancement type where we don't have any channel is an N-channel. Let's take it as an N-channel device. N-channel devices are those devices which forms an N-channel, an N-type channel, a channel formed by the electron, and it will have a P-type substrate. The whole material will be P-type substrate, but the channel will be N-type. How that will happen, we'll discuss later. But yes, it is an N-type channel formed on a P-type substrate. The N plus source and the drain are diffused or implanted into a relatively lightly doped P-type substrate, separated by a thin oxide layer. No current flows from drain to source without a conducting channel between them. There is a barrier potential from electrons to go from source to drain. Until and unless the channel is being created, no electrons can flow from source to drain, from here to here, and the current will be in opposite direction. Okay? Until and unless a channel is formed. Okay, so corresponding to a built-in potential of a back-to-back PN, this will be a PN and this will be a PN. PN junction between the source and the drain. The current starts flowing when a voltage is applied at the gate. If this is negative and a positive voltage is applied at the gate, a positive charge will be deposited at the metal oxide semiconductor insulator layer. This insulator layer will act as a capacitor with deposition of positive charge at the metal electrode. It will, because of this high deposition of charges, electric field will be generated, and that electric field will attract the negative charges from this P-type substrate near to the end of the metal oxide layer. Now this end comprises the deposition of N-type electron on the metal oxide layer, N level, will form the N channel. As the number of electrons will increase, as the number of electron deposition will increase on the other side of the oxide layer, the formation of channel began. When it is said that VGS is greater than the threshold voltage of the MOSFET, then the device becomes conducting. The VT is positive for N channel and negative for P channel. We have talked